Benelux, is that right? Benefex?
Yeah.
I knew that. It's been a long day. All right. Anyway, I shall leave you to Adam. I'm sure he's a lot more proficient at this than I am. Thank you so much.
Thank you. Well, lovely. Thanks very much, everyone. What a lovely warm welcome. Hope you've all had a fantastic first day of the conference. If you're anything like me, at this point of the day, you'll be completely learned out. There's been so much information just to take in. So what we'll do is we'll have half an hour of some lightweight career-based existentialism, and then we'll go and see who's best at table tennis and the social. How's that sound? Cool. So 30th of November. This is quite an eventful day throughout history. 1872 gave us the first international football match, and in 1979 we got the Pink Floyd album, The Wall. You know, the one with the animated hammers walking down the street in the video. Absolute classic. But despite this, it could be argued that 2022 is the most influential one yet. Why? Well, this was a release of ChatGPT. It's a large language model developed by OpenAI. And here it is depicted by one of its grandchildren. And this was a chatbot that wasn't constrained to having to refund train tickets or recite Wetherspoon's opening hours each time. For the first time in the mainstream, we could provide open-ended instructions, and we get back open-ended responses. So naturally, we asked it to write poems about our pets and to plan our next holiday for us, and also to generate some of our code. And often its output was a little bit rough around the edges, but we could keep tweaking our input to nudge it closer to what we wanted, what we call prompt engineering. But version 4 was just round the corner, and this was faster, it had more memory. In fact, according to official sources, it was even less likely to invent facts. Invent facts, that's make up things which by definition are objectively not made up, so not particularly accurate or trustworthy as far as technology goes. Then came the rise of text-to-image models like Stable Diffusion and Midjourney, and these promised to replace all of our human graphic designers almost overnight, as long as we won't bother for anything that remotely authentically resembles reality, although kudos to it for at least capturing the essence of a great British night out in this one. GPT-4 became 4 Turbo, became 4 Omni. Each one got a bit faster, had a bit more memory, sounded a bit more like Scarlett Johansson, but still likely to invent facts. So again, no more accurate or trustworthy than any of its predecessors. And then we had the viral demo for Sora. This was a text-to-video model, also from OpenAI. And obviously the video demo itself went viral, but it turned out that the video makers had the audacity to use traditional editing tools alongside prompting the window. So not the most transparent depiction of its capabilities. But that didn't stop the tidal wave of commentary. Tech leaders everywhere all began nailing their colors to the mast of where this thing was taking society. Some of these voices were open enough to admit that, well, AI is probably going to kill us all, but we should definitely forge ahead with it anyway. Others had ethical concerns, calling for a full 6-month hiatus to all AI training and research before announcing their next venture in, you guessed it, AI training and research. 105 days separated these two articles. That wasn't even long enough to source a new press release image. And then we had Devin. Not only could Devin generate code, but it uses the command line, it could deploy applications and provision the cloud. That's the full end-to-end software pipeline. Surely this is the final nail in the coffin for human developers everywhere. Well, that was until it was given a real problem space with actual constraints and requirements, at which point it published an angry blog post about how much it hated its boss and then disappeared to a dark room to play Elden Ring. Citation possibly needed for that last bit. And that brings us to the present day. Now we've got AI in, well, everything, even our pockets, which leaves many of us longing for simpler times when the height of automation was interrupting your sibling's MySpace upload by making a phone call on the landline. It's been a bit of a wild ride, but in the midst of all of the overhype and chaos, there's been real-world implications as companies scramble to try and make sense of what AI means for them, their products, and their people. So today we're going to take a peek behind the curtain of the headlines and hype of generative AI. We're going to examine the traits of human experience which AI more broadly struggles to compete with. Plus, we're going to look at some ways that we as software engineers can protect ourselves, our teams, and ultimately embrace being human. So my name's Adam Scholey. I'm part of the back-end team at Benefex. I was working on my slides and my little girl came in, she's nearly 4. I think she must have misread the title as Al is coming for your job, because she said, "Daddy, does Al do coding like you?" So I thought, yeah, why not? Here he is. By the way, no self-respecting human graphic designer would touch this request with a barge pole, so here we have our friendly neighborhood image generator helping us out. So very quick show of hands then. Who here would consider themselves a software engineer? Oh, that's, yeah, pretty much all the room. Amazing. So I want you to think about somebody asking you what it is that you do. And does the answer that you give them tend to change depending on who it is who's asked the question? And then how often do they tend to follow up, if it's your grandparent or neighbor or friend, with, "Oh, you're a software engineer. Does that mean you can fix my broken printer?" It's quite common, right? So it's quite hard for us to define what a software engineer actually is. And even for those of us in the field, and ChatGPT just went the philosophical route when I asked it. But a quick scan online throws up a range of suggestions, but these normally revolve around somebody writing applications or building some kind of program. But I think that we can distill this even further, because at our core, we're ultimately problem solvers. In fact, more than that, we're human beings who solve problems for other human beings. And throughout everything we do, there's this real human thread of traits and emotions. There's curiosity to get to the bottom of our users' pain points. There's tenacity to bang our head against compiler errors. There's fear and anxiety. What if something I do goes wrong, or I cause something to break, or worse, what if my company forces me to write vanilla JavaScript every day? And ultimately, there's satisfaction, even joy at having a tangible, positive impact on the lives of our end users. So building solutions is our ultimate goal. And to help us reach that goal, we've always developed tools. Our languages have evolved from machine code to C to higher abstractions like Java and Python and, of course, Go. And even day to day, most of us will use some kind of linter or static analyzer, probably an IDE, or Vim if we prefer re-wallpapering our house with cheat sheets. So when it comes to building software, automation has always been the name of the game, and this is actually true throughout history across wider society as well. If we look at the earliest days of the Industrial Revolution, these were all about replacing human muscle. That's augmenting our physical output, and these tools are deterministic. If we think about the combine harvester or the steam engine, for example, every time we interact with it, as long as we're pulling the same levers and flicking the same switches each time, we're going to get the same result. But more recent Gen AI tools, well, they boost our mental output, and by contrast, they're probabilistic. This means that an identical input will give us a completely different output each time, which can make them unpredictable and feel like they're somehow taking control away from us. But at the center of the story is us, it's people. We're the ones who produce and command the tools, not the other way around. And we're nearly 2 years now into this mainstream Gen AI revolution, and there's a real mixed bag of anecdotes regarding the derived value that they're giving us in our day-to-day lives as engineers. But the first thing to note is that LLMs are pattern recognizers. The way they work is, for a given set of tokens, and in our case a token is a word or part of a word, what's the next most likely token to appear in the sequence? And it repeats this process again and again until the next most likely token is, well, no more tokens. So to say that these models sometimes hallucinate is actually flattery, because that's pretty much all they do. There's even debates in some areas of the community whether this can actually be considered AI. There's nothing particularly artificial or intelligent about it. It's much closer to linear algebra, but just on a scale that we've never seen before. But either way, based on their current architecture, these models are incapable of actually understanding anything, even if most of the time their output is relatively coherent. But that doesn't mean that it's always plausible. This is a model that was asked to design the perfect railway network, and it concluded that the only real way to avoid issues with running trains is to, well, not run any trains. Now, this might be a solution which Britain's rail networks have started to adopt recently. But the question we have to ask ourselves is this a suggestion that we would accept from a human colleague? And hopefully the answer is no. But it does raise a really important point about critical thinking, because the more that we delegate our thinking to these models, the less inclined we will be to think for ourselves. And that's actually a big problem, because as we've seen, these models are not thinking for us, but they're reflecting our own thinking back to us. And this is really having a tangible impact on the quality of the software that we're writing. There was a study conducted by GitClear where they audited 153 million lines of code, and they looked at this measure we call code churn. And this is code that's committed, and then within 2 weeks it's reverted or removed or modified to the point that we can probably say it shouldn't have been there in the first place. Now, between 2022 and 23, they saw this increase in code churn of nearly 40%. And it was already increasing to a lesser extent every year since 2020, and the projection was this would go up again for 24. Now, across the same time frame, they also found the percentage of moved code had decreased, and that the percentage of duplicated code had increased. So if we combine the fact that refactoring, i.e. moving code around, is happening less, and that copy-pasting repeat code is happening more, we can see there's a tangible drop in quality in the software that we've been writing between 2023 and 4 years prior in 2020. And this was when code assistants like Copilot started to be drip-fed into our communities. Now, this doesn't tell us anything about the quality of the original prompts or how knowledgeable the devs were in using these tools in the first place. But on the surface, it looks like it could suggest that there's a direct correlation between developers using Copilot and committing, air quotes, mistake code. But as well as our tools, it could also relate as much to our mental flows as developers. It's pretty well established now that we spend far more time reading code than we do writing it, but these generally require two distinct mindsets because we're either in a flow state hacking functions at our keyboards or we're deep diving into some particular domain in a code review, for example. But when we use AI to generate our code, well, each time we prompt the model, we get a different response. So we have to keep stopping and checking. Does this code look okay? Is it reasonable? Does it use patterns that I'm using elsewhere in my code base, or are they wildly different? And so if we're having to read and reason about our code whilst we're in flow state writing it, this is actually increasing our cognitive load as developers. And we can see why it therefore might be tempting to just skim read a suggestion. Yeah, this kind of looks okay, and then accept it into our code base. And so the ultimate question is, can these tools do our jobs for us? Michael Richmond did a great lightning talk at GopherCon US last year, and he concluded that this was a resounding no, that they couldn't. They can't think for us anyway, but the bit that we should be able to entrust them with, generating the code, well, he found that they weren't particularly consistent here either. So it sounds like these tools have a pretty bad rep, but that doesn't mean that they're completely useless. They can produce summaries of things that we turn to Google or Stack Overflow for in much shorter the length of time than it would take us to click through tons of links ourselves to find the information we need. And also, the better defined and more isolated our requirements are, the more usable the code that they do generate actually then becomes. Liam's talk earlier actually did a brilliant job of illustrating just how rapidly Copilot and similar code assistants are evolving. But it's all about the context and the quality of the prompts that we give them and understanding how we command them as our tools, which is generally a good rule of thumb regardless of what our tools are. So we're still not there with this low-code, no-code promise of never having to write another line of the stuff ourselves again. But these tools are definitely a power-up along that road, and they're evolving in their capabilities all of the time, but it's still up to us to learn how to actually use them to get the best out of them. So, let's look now at the nature of AI much more broadly, because there's lots of talk about machines superseding human intelligence, but this is essentially a category error because they're fundamentally very different things. You see, humans encompass this vast array of different kinds of intelligence, like visual and verbal and mathematical. Often our memory lets us down and we struggle with things like cognitive bias, but we also have this amazing flexibility to connect the dots and forge new pathways in our understanding. Whereas machine intelligence is just an algorithm. It doesn't know if what it's telling us is meaningful or offensive or really grounded in fact, even if we do project human attributes onto them like thought and reasoning. We are pattern-seeking creatures ourselves, after all. So there's definitely elements that we should want to harness, like memory and speed, but it's crucial not to lose the advantages of our own minds as well. And we have this fascinating quirk of our own intelligence that we call imposter syndrome. You may be familiar with it. It's this phenomenon where we doubt our own skills and accomplishments. We put our successes down to luck or timing and fear that we're only one mistake away from being found out as a fraud. Now, it's often seen as a weakness in society, but ironically, it's the highest performers amongst us who struggle with it the most. So if we can learn to harness it in the right way, it could become crucial to thriving in a world that's saturated by AI. So let's look now at some unique human traits which imposter syndrome can actually help us to leverage. There's a whole range that I could have included here, but for the sake of pithy rhetoric, there's only 3 of them, and they all begin with the same letter. The first one is empathy. You may have seen the Disney film Inside Out. The story follows the main character, Riley, and inside her head lives all of her emotions. Each one's a different character. There's joy, sadness, anger. Not surprise, though. Once you've recycled the same 3 story arcs 500 times, there's very little surprise left in Disney films these days. But emotions are incredibly powerful things, and when we work with technology, we have to remember that we're ultimately building it for other humans who have emotions. And these dictate their behaviors, their moods, and even their decisions. So if you want to understand our users, then we need empathy to know what makes them tick. But we can't even scientifically define what emotions are, so any claims that AI can understand them are way off the mark. Try this if you haven't already. Ask an LLM to tell you a joke and then explain to you why it's funny. Nothing kills humor quicker. It's like being at a stand-up comedy night for Daleks. Now, on the other hand, imposter syndrome can help us develop soft skills like communication and compassion and improve our interpersonal relationships. I think we're already pretty good at this in our tech communities. You might be familiar with the HugOps hashtag. This usually starts trending when there's a global outage of some core component or dependency that takes out half of the internet with it. And it's basically a show of solidarity to the engineers involved in putting out the fire. It's a kind of we hear you, take as long as you need kind of thing. We have this natural tendency to relate to each other in our field, and this higher emotional intelligence means that we can reduce conflict in our teams, we can communicate technical concepts more relatably, and provide more constructive feedback in our code reviews. And all of these are key metrics to project success. The next one is expertise. This is ultimately what makes our labor valuable, but you probably wouldn't have much faith in your surgeon if they weren't holding a scalpel. Also, likewise, an air traffic controller without radar is just someone stood in a field staring at the sky. So expertise relies just as much on knowledge of our tools as it does our subject area. Jeff Hinton had plenty of thoughts on this. He said that deep learning directed at radiology was about to usurp human practitioners in a short space of time. I'm not quite sure why you picked on radiology specifically. We could say the same thing of most knowledge fields. But when he said this at a conference in 2016, he gave it a 5-year time horizon. So the question is, was he right? Chexpert from Stanford University is a baseline model and dataset of over 200,000 chest scans. It takes new scans as input and then provides a diagnosis along with a rating of how confident it is, kind of like how an expert radiologist might work. Now, using the model alone without extra context performs about as well as 6 out of 10 radiologists. But combining the model with human expertise actually performed worse in a recent study. And here's why. When the radiologists and the model disagreed on their diagnosis, but neither were particularly certain, then the radiologist would defer to the model. But when both were pretty confident in their conclusion, then the radiologists tended to override the model and stick with their own judgment. But in almost all cases, the correct diagnosis was actually the other way around, which seems counterintuitive. But when the model's degree of certainty is high, this is based on more X-rays than the radiologist can possibly recall in the moment. And so the model's diagnosis is much more likely to be right. Whereas when both had a low certainty, well, the model still isn't confident, even based on over 200,000 scans. So at this point, it's the radiologist's own intuition and experience that prove the deciding factor. And this is a great example of what we call automation bias, which is trusting the judgment of a machine learning model over your own simply because it's been trained on more data, so must therefore be more trustworthy. So we therefore need to trust human intuition and judgment far more, especially in complex and ambiguous situations. If we experience imposter syndrome, then we know that our knowledge isn't always going to apply perfectly in every situation. So we have this heightened awareness to adjust our approach and seek out additional information whenever we need it. And this is vital when we build software. As human engineers, we can draw on our past experiences to assess what our code's doing, why it might not work in all scenarios, and ultimately, what are the trade-offs. And this is becoming even more crucial as we build for scalability. Decoupling our architecture increases the complexity of the interconnected parts. And it's at these boundaries where the most fragility is often found. So the wider the context and scope that we're dealing with, the less AI is capable of assisting us effectively anyway. The last one's ethics. If we think about Cambridge Analytica in 2016, and of course the Post Office Horizon system in the early noughties, ethical considerations have been a fundamental part of the software that we build long before the recent rise in AI. But if you ask an LLM what's the difference between human ethical conscience and its own moral compass, it'll tell you that it doesn't even have one. As Professor John Lennox notes, how can we build an ethical dimension into a machine which doesn't have a heart, a soul, or a mind? A recent YouGov poll of 5,000 UK adults found that nearly 3/4 would prefer a human to review workplace misconduct. You see, an algorithm might flag an employee for underperformance, but it won't take into account the personal struggles that they might be experiencing, because it can't. It's just not been built to do that. AI can't consider the ethical implications of its own output. But for humans, particularly if we experience imposter syndrome, well, our tendency is to be more conscientious, to pause and reflect and double-check, and this avoids overconfidence. It minimizes the risk of us making unethical choices. And as software engineers, there's a lot at stake. Only we as humans can decide if our coding practices are truly secure enough. And what about the privacy of our users' data? Are we complying with regulations like GDPR? And how are we handling sensitivities around communication with our human users? For example, if we're approaching Mother's Day or Father's Day as an e-commerce business. Human oversight has to remain integral to AI apps to make sure that the software that we build continues to be equitable and just as we move into the future. So we've looked at what's really going on behind the curtain of the current AI hype. And we've also explored where the human-shaped gaps are that this AI wave we're riding keeps leaving behind it. Now let's look at what we can do, not just to survive, but thrive as we continue to march into this new AI frontier. The first tip is to prioritize our well-being. As we've seen, the more that society and industry become dominated with AI, the greater the need for skills that are soft and uniquely human. But the latest index report from Stanford found that working with AI can make us feel demotivated, much more isolated and far lonelier. So we have to recognize the relationship between mental health and team performance. A huge well-being driver in the workplace is this concept of psychological safety. A Google study called Project Aristotle concluded that team members must be comfortable taking risks and speaking their minds. It's the only way that we're going to get real opinions about where our people are experiencing the most friction, or how limiting our tech debt is, and how to actually resolve it. We need to shape and architect our software teams so that everyone knows that their colleagues support their actions, and that they won't be ridiculed if something doesn't go right, which they've suggested or promoted. And using AI might provide us with a productivity boost, but if we're in any kind of leadership position, then it's up to us where we place this within our teams. Do we add to our people's workload or to their well-being? LLMs repeat the expected patterns that they're trained on, but solving complex problems requires those patterns to be broken. So how about giving engineers more opportunity to experiment? Imagine a world where we could try and fail our proofs of concept much more quickly thanks to AI. Our feedback loop would shrink considerably, and we can make sure that we're delivering the right solution to the right people in the right time frame. And all of this from simply investing in our people's natural passions, rather than adding to their obligations. The second tip is adopt a growth mindset. We've always had new libraries and languages and frameworks coming out in nearly every part of our tech stacks almost every day. It's a bit of a cliche now, but we're already used to what feels like this endless hamster wheel of learning. But ultimately, a tool is just a tool. If we become too attached to a particular language or framework, this limits our opportunities. And using Gen AI can actually help us plug knowledge gaps in areas that we're less familiar with. So don't be too precious about your current tool set. Also, look to add cross-disciplinary skills. The more knowledge that we can acquire of related fields like data science and cybersecurity, well, the more effective that we become as engineers and more versatile as team members. And we don't even have to stick to tech. If we learn how to persuade and convince and influence key decision makers, well, that's much more likely to increase our value as AI automates more technical aspects of building software. Because as programmers, we don't just churn out code. The closer that we are to our users, the closer we are to the human gap. So this is ultimately where we can innovate the most. As AI automates more in the middle of the software lifecycle, well, our highest value adds become deciding what our system should do, and then evaluating whether it actually does it. Of course, AI can help us reduce our time spent coding and catch bugs, but there's plenty of quality measures that AI won't even touch, like the value of the features that we're delivering, or the cost of not delivering certain features, or delivering the wrong thing. For these insights, we need to discuss with and react to our users. But in the meantime, the world still uses applications, so our typical development practices aren't going away anytime soon. None of this is as simple as training a model and throwing some data at it. We still need to deploy, host, and test, not just the models themselves, but also the APIs and the interfaces that we build around them. Because these are ultimately the glue between the AI advancements themselves and actually getting stuff done for our organizations. Just look at how our patterns have changed over the years as well. We've gone from monoliths to microservices. Some of us are creeping back to monoliths. And the patterns that we adopt for AI systems will likely look entirely different again in the future. So the key is to be adaptable, to keep an ear to the ground and make sure that we continue to experiment. So our last tip is to embrace our imposter syndrome. The faster that AI advances, the more that imposter syndrome becomes this globally shared experience that transcends roles and titles. It effectively unites us as fellow members of the human species. As engineers, the more that we grow, reflect, and adapt, the more that we realize there's never a one-size-fits-all solution. The only real answer is, it depends. And as teams of humans, we can authentically hold each other to account in a way that AI can't. Why did you do it like this? What were your thought processes? Why this pattern? Those who are newer to the field are particularly good at this because they generally bring a fresher, more pragmatic perspective. But if AI replaces junior engineers, which is a big debate currently, then who are the seniors of the future? So we mustn't eliminate imposter syndrome from our lives, but learn to live alongside it. Mark Bradley, who's here today as a fellow gopher and speaker. Hello, sir. He did a brilliant talk at PHP Scotland a few years back where he goes into a lot more detail. Definitely recommend you check it out. But ultimately, the key to dealing with imposter syndrome is being open to it. If we're all transparent about our struggles and we're vulnerable with our doubts, then it gives others a framework in which to view their own. So the more normalized that we can make it, not just within our industry, but hopefully across wider society as well. And really interestingly, we're starting to see imposter syndrome actually being driven by using AI. It's something that we call the informed novice phenomenon. This is where we use LLMs to really quickly gain a broad understanding on a particular topic, but we lack the 10,000 hours of practice that's typically needed to become an expert. So we can talk confidently about it, but internally we're questioning our own authority on it. And it raises a great question. Is true expertise defined by the depth of knowledge acquired over years, or the ability to navigate the breadth of knowledge that we now have at our fingertips? As we're bombarded with more and more information, being what we call expert enough enables us to learn efficiently and apply our knowledge flexibly. So some of the most valuable human skills of the future will likely become our abilities to context switch and to prioritize. So is AI coming for our jobs? Well, maybe partly, but only really the elements that aren't fully utilizing our uniqueness as humans anyway. Ever since the days of punching holes in cards, we've always adapted to new tools that improve the way that we write software. But our motivation has remained pretty constant, to solve problems for human beings, and the only thing that changes is the complexity and sophistication of the problems that we're trying to solve. Humans need to remain in charge of big-picture strategic choices. A self-driving car having to seek human approval each time it needs to turn the steering wheel doesn't actually make any sense. But we should ensure that the human rider at least has to pick the destination. Imposter syndrome has never really been a weakness, despite how we tend to frame it in society. In fact, it's becoming more valuable than ever as our world continues to be saturated by AI. The ability to think critically, to say, I'm really not sure, and to relate to others on a personal level, these all give us the ultimate advantage over an AI whose nature is often to assert falsehoods and lack the ability to question itself. So where do we go next? Well, if the promise of generative AI to truly transform society is ever actually going to happen, we have some significant obstacles that we need to overcome first. Mainly, we have to be able to put far more trust in the models than we can at present. The team at DeepMind discovered that in order to scale models, the availability of new training data is just as important as compute power. And another study called Lambda found that even as models do scale, they become faster, but not necessarily any more accurate or precise in their output. Now, the more model-generated content that we're putting out there in the big wide world, the lower the proportion of human-generated content, and this reduces the availability of novel training data. We call this model collapse. It's where models are retrained on their own output and essentially eating themselves and cutting off their own oxygen supply. It's like a photocopier. making a copy of a copy of a copy until we converge to this point of minimal to no progress. Here's two graphs which show the perceived ability of LLMs to comprehend their input. And crucially, both graphs show this diminishing point of returns that supports this theory of model collapse. There's a wonderful irony to the fact that this new wave of tech starts to decline in quality as soon as it stops being fed the very thing it's intended to outperform. And if continual human input is required to keep these models alive and progressing, then what does that mean for their effectiveness long term? We may be seeing this exponential improvement in speed and cheaper costs, but it's correctness that will determine disruption, not a whole host of factors which make it better at being wrong. Ultimately, it comes down to accountability. None of us should be outsourcing anything that's truly mission critical to a system that can confidently agree with you when you tell it something that's fundamentally false. A few weeks ago, we had the world's first AI act of law coming into force in Europe, but regardless, the current ecosystem is pretty unsustainable long term. The sheer power consumption of data centers when scaling and training models just heaps further energy woes onto a planet that's already in crisis. And many people are drawing parallels with the dot-com bubble of the early noughties. Here's where we had an initial wave of startups which were highly overvalued, but when the bubble burst, we eventually ended up with email and e-commerce and social media, all of which we'd struggle to imagine modern life without today. And we could be seeing the same cycle play out again. Humans love to exaggerate, especially in a world that's driven by clickbait, but the reality often turns out to be almost disappointing. Once the dust settles, progress tends to be a lot slower, much less dramatic, and nowhere near as newsworthy. And whatever new smoke and mirrors demo goes viral tomorrow, it's crucial to remember that AI systems are the product of human ingenuity, complete with all of our imperfections and cognitive dissonance. We've gone from killing each other in colosseums 2,000 years ago to loving our neighbor and protecting the weak and the vulnerable, and developing empathy and patience and compassion as a species along the way. But is it really in our best interest to outsource all of that to a mirror which reflects the world, but without a heartbeat? To a silicon entity that sees but doesn't feel, that computes but doesn't care? And we still don't understand how any of this gives rise to consciousness or sentience or thought. And whatever AI eventually becomes, whether artificial general intelligence is achieved or not, we're trying to emulate the ultimate infinite complexity. That's the conduit to our own subjective conscious experience, which is already several 100 million years of evolution ahead of us. Above all, if we retain our humility, remember that nature had already got there long before our species could even conceive of the very notion of intelligence, then hopefully we can keep our collective feet on the ground and fully embrace being human after all. Thank you very much.